Hello everyone, welcome back to my channel. Today we are going to explore something really exciting, how to expose documents as a resource using MCP with Spring AI. This is one of the topics which isn't talked about more as compared to MCP tool, and the number of tutorials for exposing resources by MCP server are also less. Before we dive into the code, I want to discuss why use MCP resources? Why not just RAG it? Let's take a quick refresher on RAG. What do we do in RAG? RAG, also known as Retrieval Augmented Generation, is a technique where we take documents and split them into chunks, convert those chunks into vector embeddings, store them in a vector database like Pinecone or VV8, and when a user asks a question, we embed the question, search the vector database for similar chunks using semantic similarity, and pass those relevant chunks to LLM as a context. The LLM generates an answer based on that context. Let's see the advantages of RAG. RAG is incredibly powerful when we want AI to work with a large collection of documents. It can search and retrieve semantically similar content, even if the wording is different. This makes it a great choice for building Q&A systems or for retrieving knowledge from big text repositories with accuracy and speed. Now, even though RAG is powerful, it does come with its challenges. First is infrastructure overhead. To make RAG work, we need embeddings, chunking, a vector database, and a full document ingestion pipeline. That's a lot of setup so that AI can read and recall information. Real-time updates are also difficult. If a document changes, we must rechunk, re-embed, and update the index. For large documents, this takes time, so RAG isn't ideal when you need instant updates. Third is loss of structure. Chunking breaks documents into small pieces, meaning the model can lose context like page order, section hierarchy, or relationships between parts of the content. And it is not ideal for structured or dynamic data. RAG works best with static, unstructured text. For things like database records, API responses, or fast changing sensor data, it doesn't shine as much. This is where MCP resources come into picture. MCP resources are one of the core primitives in MCP. They represent contextual data that AI models can access. Resources can be files on disk, database records, API responses, live sensor data, configurations files, or anything that can be represented as text or binary data. Now we need to understand when to use RAG and when to use MCP resources. RAG is the right choice when you're dealing with a large number of documents and need semantic search, meaning the AI can find context based on meaning and not exact wording. It's well suited for relatively static information like knowledge bases or Q&A systems, and it helps reduce token usage by retrieving only the most relevant chunks. When should you use MCP resources? MCP resources make more sense when your data is smaller, constantly changing, or needs real-time access. It works great with structured formats like JSON, logs, or CSV files. And since the AI reads the entire context instead of chunks, it keeps full context without complicated infrastructure. We are going to build an MCP server that exposes documents from a directory, makes them available to AI applications, and automatically detects and sends updates whenever those files change, all in real time. Also, If you like this video, please subscribe to the channel. Let's create a new project. Spring AI MCP Server Resources. I'll set the JDK version as 21 and let me correct the package name. Next, let me choose MCP Server as dependency and the project is created. Now I need to do a tiny change. I need to update the Spring AI dependency to Webflux because we will be running this in SSE mode. Also, I need to add one more dependency of Commons IO. This is required as I want to set up a file watcher. Now let me do a Maven update, and once it is done, let me quickly go to the properties file and set up the required properties for me. Here I am setting server name, version, and I am setting resource change notification as true. By default also this keys value is true. I'll set the logging level for the AI as in debug mode. Okay. And server port to 8040. You can choose whatever port you want to run this MCP server on. Now I also want to declare the path where I will be storing my resources. Resource for me is just a txt file that I am exposing. So this is a dummy txt file that I have made. It's a cover letter.txt and I will use this in the properties file also. I will declare this in the properties file. Same path, and let me correct that backslash. Now let's go and create a bean for exposing resources. This bean is going to return a list of sync MCP resource specification. That means in the directory that we have specified, for every file present in the directory, it will return sync resources specification. And since there can be multiple files in the directory, it has to return a list of sync resource specification. Now this method's responsibility is to return sync resource specifications list. First, let me try to set up the path from where I have to pick up the files. I will use @value to fetch the path from the application properties. With this, I will be able to access the path from the application properties, and I now have the responsibility to find out all the files which are present in this directory, iterate through them, and find out the sync resource specification for all of the files. So I am going to stream on the paths, and for each path, I am going to call a method which is going to give me sync resource specification. As of now, I have not created that method. I am just declaring it, and I will assume that that method is going to give me the sync resource specification for that particular file. That's it. We will see how to implement that method very soon. So let me iterate on the path, and for each path I will invoke this method. Let's call this method at get resources specification, and I will collect this into a list. That's it. And now let's start with our implementation of get resource specification. Let me quickly fix the compile time errors. I think I'll have to change the path variable name as it is already being used. The method gets created, and this method is going to return me sync resource specification. In each iteration of this loop, I am going to be passed each and every path of the file, and using the path I will return the MCP sync resource specification. For doing that, first I have to generate some metadata for this method. So I have declared file name, absolute path name. File URI is important because all of these variables we are going to use when we are creating the document resource. Document resource is nothing but a container which holds the metadata for a particular file. Here we have created MCP schema.resource, and we will use the builder pattern to set all of these values that we have with us: file name, file URI, MIME type, etc. Description is something that we set for the large language model. For my use case, I am just setting description as the file name of the document, and this document resource is now built. After this, I'll make use of sync resource specification constructor, and this constructor takes document resource which we just created, and the second argument is a buy function which takes exchange, request, and returns read resource result. So now let's implement this buy function. First argument is pretty simple, document research. For second argument, we will have to implement this buy function. The implementation is pretty simple. We just have to make use of exchange and request to fetch the text content of that file. Our file is in TXT format, so we have to read the file. After reading it, we got the text content, and using this we have to generate text resources contents. Now we have text resources content, and using this we will be able to return read resource result, which is exactly what this buy function wanted. And at the end, since we have received the sync resource specification, we will just return it, return spec. And now the responsibility of this method is complete. Let's take a quick look at what we have done in this function. First, we had created a document resource using the metadata of the file, like file name, file URI, MIME type, etc. And then we had implemented the buy function using exchange request, and we returned read resource result. And finally, we got the sync resource specification which we had to return for that particular file. Now let's implement a file watcher. The responsibility of the file watcher is to watch the file which we have just made for any kind of changes, so that if any change happens, we can notify the MCP client. For this reason only, we had added Commons IO dependency. We'll create a resource watcher class, make it a component, and we'll add a dependency for directory, which we are going to read from the application properties using @value. We will also add a dependency on MCP Sync Server. Using this, we are going to notify the client. We need to set up a watcher for us, so we don't have to call this watcher each and every time. We can just do it with the help of post construct. We have made a method start, and within this method we are going to create an observer for our file, and this observer is going to monitor the changes in this directory that we had specified in the application properties. Now there are many methods that we can override which can monitor the changes in the directory or the changes in the file itself. I don't need to override all the methods, so to avoid doing that, I will make use of adapter pattern so that I can only override the methods which I am interested in. So here you see that I am using override on file change, and it is going to monitor only updates which are happening on this file, and once I capture the update, I will be notifying the MCP client that something has changed for this file. If you want, you can override other methods from this adapter also, like file deletion, file creation, etc. And I'm setting up this monitor so that it can run after every 2 seconds. Now this piece of code is set up pretty nicely. This observer will be keeping on observing files after every 2 seconds, and we have an option to override a various plethora of methods that we have. To keep things simple, we are only overriding on file change, and we are going to monitor only updates on the file, which is coverletter.txt. Let me quickly start the server, and in the console logs you will see registered resources as 1, because in the directory that we had specified, that directory had 1 file. If you had more number of files, it will say as many number of registered resources. I had 1 file, so it is saying 1 resource registered. Let me start MCP Inspector. This is a tool which helps us in testing and debugging our MCP server, and now it is up. So I was setting the application for 8040 path and endpoint /SSE. Let me connect to it, and I will have a list resources tab. Once I click on it, I will be able to see the number of resources that I have exposed. For this example, I had only 1 resource, coverletter.txt, and I am able to see the content also over here. Now let me make changes to coverletter.txt and see whether I am able to notify client or not. So let me make a tiny change, and let's say if I change experience from 10 to 5 and hit Control Save, let's see what happens. We see a server notification, list changed. This means that the MCP server was able to successfully notify that the resource was changed. Now the MCP client will receive this notification, and it is going to refresh the resource which it loaded previously, because if it will not refresh, it will have the stale data. After refreshing, we see that we were able to fetch the latest data, which is not 10 but 5 years of experience in the content. This is the same thing which MCP client also has to do before sending this data to large language model. At this moment, we were able to create an MCP server to expose resource, and we were also able to notify whenever any changes happened to the resource. Now what next? After this, we are going to create an MCP client to use MCP Resource while answering the user's questions. We will also handle the notifications which were sent by the MCP server on resource change. All of this code, whatever I had shown you for exposing resources via MCP server, is present in the Git repository shown here. I will also share the link of this repo in the description box. Thanks for watching this video. You can also check out the other videos from this channel.